Okay, so chapter 9, we're going to look at how to sketch graph. 9.3 is all about the graph of simple harmonic motions. So there are a few types of graph that you have to know. The first three graph is changes with time, which is our xt graph, and then vt graph, and at graph, which these three equations, it relies on time. Okay, it changes with time. So, which means you have to sketch the graph based on the equations with time. All right, so for example, you look at questions 1, you have x equals to 2 sine 2 pi t. So this is the equations that we're going to use in our graph sketching. We're going to sketch graph based on these equations. And then there's another three graph that we have to know, which is energy, okay, the graph for energy, which changes with displacement. All right, so we don't look at energy changes with time. In our syllabus, we are just going to focus on energy changes with displacement. So for examples, we have a k against x graph, and then we have u against x graph, and e against x graph. So these are the three graph, okay, that we're going to look at after this. So changes with displacement, right? Changes with displacement. So at different displacement, it has a different values of energy. So for the one just now, x, v, and a, at different times, you will have a different values of x, v, and a. Okay, so one, it depends on time, and one, it depends on displacement. Now, do we have the graph of energy changes with a time? Yes, we do, but that is not in our syllabus anymore. Okay, that's why we can skip that one. So in our syllabus, we're going to focus on just these 6 type of graph. Okay, you have to know how to sketch xt, vt, at, and also kx, ux, and ex graph. So let's look at questions 1. Now, questions 1, the displacement x of a particle in simple harmonic motion, it varies with time according to the equations. X equals to 2 sine 2 pi t. Now, whenever you are given an equations, it doesn't matter whether it is a calculations type questions or it is a graph sketching questions. What you have to do, the first thing that you have to do whenever you're given an equations like this is to compare it with general equations, which is x equals to a sine omega t. Okay, so by comparison, we found that a is equals to 2. Now, what is the unit for a? Again, you look at the unit for x. So x is in terms of cm. Therefore, a is also in terms of cm. And then by comparisons, we have omega equals to 2 pi radian. Now, radian per second or per minute, it depends on the time. Okay, so t is in second. Therefore, we have omega equals to 2 pi radian per second. So these are the informations that we obtain by comparisons. Compare between the equations given and also the general equations. So now let's look at questions A. Questions A asks you to sketch a displacement against time graph, which is a xt graph. Okay, question is asking for xt graph. So how are we going to sketch xt graph? Well, first thing, of course, you need axis. Okay, you need the x-axis and also y-axis. So x against t graph. So remember, your graph should come with a negative y component because you have positive displacement and also negative displacement when something is oscillating. Right, so the y component, the y-axis, it should come with both positive and negative axis. Okay, now the things that you must include in a graph is the amplitude and also period. These are the things that we must have in a graph. So just now, by comparisons, we obtained the values for A already, which is 2 cm. Then how about T? If you recall the things that I told you guys before, whenever you are given omega, okay, then you can find T. Why? Because omega, T, and frequency, they are one big family. So omega equals to 2 pi over T. So rearrange equations, you have T equals to 2 pi over omega, which is then equals to, okay, 2 pi divided by 2 pi, which give you 1 second. So this is the period, and this is the values that we're going to put in our graph. Okay, so when to insert value in our graph and when to leave it as unknown. Now, if you are given a value in a questions, then you need to calculate the information needed. All right. Sometimes you are not given any value. The question just tells you now you have something that is oscillating. So sketch a graph to represent the motion. So in that case, what you have to do, you just sketch the graph and then you label the unknown as A and T. But now for this question, because you are given omega, which means you can calculate T, therefore you need to calculate it, okay, in order to insert the values into the graph, in order to put the values in your graph. Okay, so sentiasa pelajar tanya saya, bila nak masukkan nilai, bila tak payah masukkan nilai. Senang saja. Tengok soalan dia. Kalau nilai diberi atau nilai boleh dikira, bermaksud Anda kena masukkan nilai dalam graf Anda. Okay? Kalau dia tak bagi nilai, dia cuma suruh Anda sketch satu graph to represent, okay, untuk mewakili sesuatu motion. Then in that case, you don't have any value, then you straight away just sketch it and label it with the A and T, okay, with the variables, with the symbol. Okay, so kalau ada nilai, kalau boleh kira, Anda kena kira. Kalau tak boleh kira, contohnya soalan A dia suruh Anda sketch, soalan B dia suruh Anda kira. Bermaksud A, kamu tak payah masukkan nilai. Right? So that is how we determine whether we need to include values in our graph sketchings or not. Okay, now let's go back to the graph. So how are we going to sketch the graph then? You look at the equations. So equations given is x equals to 2 sine 2 pi t. You have a sine graph, okay? And according to this question, this equation, it shows us that our initial phase angle is equal to 0 radian, okay, which means the object starts from equilibrium position because we have a sine graph. If you have a cos function and initial phase angle is 0, then it means your object starts from amplitude. But now you are given a sine graph and initial phase angle is equal to 0. Therefore, we know our graph is start from equilibrium position. So from x equals to 0 and t equals to 0, you sketch, okay, you draw the graph for a sine function. So the shape of a sine function is just like this. So after you sketch it, next step, you just label, all right? So amplitude is 2. Okay, remember to include unit in your axis. So you have amplitude 2, origin is a 0, and then negative amplitude is negative 2. After one complete oscillations, you write 1 here because that is the period. Okay, that is the period. Now, another question that students like to ask me, how many revolutions, okay, do I need to draw in my graph, okay, in my sketching? It depends on the questions. For questions like this one, because it didn't say anything, so you can leave it in a one cycle, okay? You can draw 1, you can draw 2, you can draw 3, it's up to you. But sometimes questions will ask you to sketch the oscillation, for example, for a time in between t and let's say 2t, 2 times of period. Then you have to draw 2 cycles. Okay, you have to draw 2 complete revolutions. No more, no less. Okay, exactly 2. So if it says 0 and then t and then there's less than 3 capital letter T, 3 period, means it's asking for 3 oscillation. All right, so that is how we determine how many cycles do we have to draw in our graph. So if the questions didn't say anything, then you can leave it like this. Okay, the most important thing is you got the label. Okay, you got the label for axis. Okay, axis with unit, and then you got the value for amplitude, you got the value for period, and with a correct shape. So usually these questions, one question is worth 3 marks in your exam. Okay, satu soalan ini dia bernilai 3 markah. So how to obtain 3 marks? 1 marks for the axis with unit. Okay, x in the cm, t in second. That is 1 mark. 1 mark for all the values that you calculate. Okay, for example, period is equals to 1, amplitude is equals to 2. So you got all the labels, all the values correct in your graph. You got another 1 mark. And the last mark is being given to the shape of the graph. Okay, so you got the right shape. Then another 1 mark. So usually this question is worth 3 marks in your final exam. Okay, now let's look at questions B. Okay, so we are done with questions A. Now questions B is asking for velocity against time graph. Well, you don't have equations for velocity. Velocity against time means you need an equations with time. But now you don't have the equation. But what you can do, because you are given x, and we know v is equals to dx over dt, therefore we can differentiate the equations given. So d over dt, and then 2 sine 2 pi t. Now, of course, if you think it's very hard to differentiate an equations with value, you can always differentiate the general equation. Okay, you can always differentiate the general equation, and then after that you plug in the value. So it's totally up to you. Okay, which one is easier? It depends on you. It's up to you. All right, you can choose whether you want to differentiate the equations with value, or whether you want to differentiate the general equation, and then you substitute a and omega into the equation, into the general equations that you differentiate. Okay, you derive. Okay, so v equals to dx over dt equals to d dt bracket 2 sine 2 pi t. So now we differentiate it. We are going to obtain v equals to 4 pi cos. Differentiate sine, it gives you cos. Okay, so 4 pi cos 2 pi t. So this is our equations. Okay, now how are we going to sketch the graph? Well, the question is asking for v against t. Obviously, v would be your y component and t would be your x component. Now, the next questions would be, what is the unit? So if you look at the question, your x is in terms of cm, and you differentiate the equations of x. Therefore, your v should be cm as -1. Okay, cm as -1. And t is still in second. Okay, now the next part. Okay, next part I want you to take note. This is where students always got it wrong. When it comes to v against t graph, the maximum value is no longer a, right? A is just represent maximum displacement. So maximum displacement, we have a in our graph of x against t, which is a equals to 2. When it comes to v against t graph, the maximum value that we're going to put in along the y-axis is the a omega, which means it's a 4 pi. Okay, so the general equation is v equals to a omega cos omega t. So the things that we need to put in our y-axis is not a, but it is a omega, because now you are looking at velocity. Just now we put a in a y-axis because that one represents maximum displacement. A is for displacement. Now our y-axis is velocity. So you cannot use a anymore. Okay, but in fact, you're going to use a omega. So a omega is a 4 pi. So we have a graph where the maximum value is a 4 pi. Your maximum velocity is 4 pi, 0. And then the minimum value, the negative value would be -4 pi. Okay, so how to sketch the graph now? If you look at the equation, now you have a cos function. A cos function with 0 initial phase angle. Okay, your initial phase angle again is equals to 0. Therefore, you just sketch the shape of the cos in the graph. So cos is start from maximum. Okay, so this is the shape of the graph. Done. Okay, so this is the answer. So you have a maximum 4 pi, negative maximum, -4 pi, and then time taken to complete one revolution. Remember to label the period, which is still equals to 1 second. Okay, 1 second. So that is the graph for questions B. Okay, velocity against time graph, where we start from differentiations. You need to differentiate the equations. Okay, so the next questions, okay, A against T. So again, A against T, you don't have the equation, but what you can do is differentiate equations for V. So A equals to dV over dt. Okay, so d over dt, differentiate the v, which is 4 pi cos 2 pi t. So a is then equals to, now you differentiate 4 pi cos 2 pi t. Cos, okay, differentiate cos, it gives you negative sign. Therefore, you have negative 8 pi square sine omega t, okay, which is a 2 pi t. So differentiate cos, it gives you negative sign. Okay, differentiate cos, it gives you a negative sign. Therefore, A is equals to a negative value, negative equations. So negative 8 pi square sine 2 pi t. So now I can sketch the graph. Okay, A against T graph. So A is here, T is here. So again, what is the unit? Well, because your V is CMS negative 1, so you differentiate B, which means A is CMS negative 2. And time is still in second. Okay, now, what is the maximum accelerations then? If you look at the equations, okay, now the general equation A is equals to negative A omega squared sine omega t, okay, omega t. So the maximum value is now equals to A omega squared. So we need to substitute the values of A omega squared in our y component, okay, as our maximum accelerations and also a maximum negative acceleration. So accelerations positive maximum is A omega square, which is 8 pi squared. 0, and then here we have negative 8 pi squared. So be careful, yeah. This is where students always got it wrong. Students always write just A because they say A is the maximum amplitude. So, well, maximum amplitude in a graph means is the maximum value. No, that is a misconception. That is wrong, right? That is wrong. So maximum value, you look at the value in front of the trigo function. So in front of cos 4 pi, then that would be our maximum value. In front of sine, we have 8 pi square, so that is the maximum value in A against T graph. Now, how are we going to sketch the graph then? If you look at the equations, equation is now a negative equation. So like I told you just now, you differentiate cos, you got a negative sign. So negative sign means that you are going to draw an inverted sine functions. Okay, sine yang terbalik. When there's a negative means you're going to flip the shape of the graph over. Okay, you flip it over. So just now we have a shape as shown in the questions 1. Now I'm going to flip it over. Okay, I'm going to flip it over so it will look like this. So this would be my negative sine function. Kalau kamu ada negative function, bermaksud kamu terbalikkan dia. Okay, terbalikkan graph tersebut. So just now, when I have a positive sign, my object starts from origin and then it head towards a positive maximum. So now I have a negative sign, object still start from origin, but it heading towards a negative maximum. So this is the negative value, the maximum value, and again, period is equals to 1. Okay, so label period. So done, okay, that is how you solve the questions. So sometimes questions might just ask you to sketch one of it. So you yourself have to know which equations to use, how to differentiate the equation, what is the things that you need to include in the graph. Okay, benda yang kamu kena masukkan dalam graph, macam mana kamu nak kira dan sebagainya. Alright, so this is the answer. I give you 3 minutes, okay, 3 questions. I give you 3 minutes to write it down. 3 minutes untuk kamu catat macam mana kamu nak sketch graph from one equations given sampai kamu dapat A against T graph. Okay, so 3 minutes for you to write it down. Okay, so if you are done, you may try questions 2. Questions 2 is very similar to questions 1, but now you are given an equations in terms of cos. Okay, rather than sine, now you are given an equations in cos. So try to solve it. Okay, try to solve it. So I will discuss questions 2 with you at the 40 past 2. Alright, so 2 jam 2.40 saya akan sambung lagi di soalan 2. Okay, so I give you some times. I want you yourself to try questions 2 first. See whether you know how to differentiate it. See whether you know how to sketch the graph. Okay, kita sambung lagi pada jam 2.40. Oh, I forgot to switch on the mic. All right. So now let's look at questions number 2. Questions number 2, again, we have a general equation, x equals to 2 cos 2 pi omega t. So one thing you have to be careful, because now you are given equations in terms of cos. Therefore, for general equations, we use the one in cos as well. Right? So cos and cos. So by comparisons, we have a equals to 2 cm and omega equals to 2 pi radian. And once again, because we have omega, we can then determine the values of period, because period is a mass in our graph. So t equals to 2 pi over 2 pi. Once again, we have 1 second. Okay, so now we have the information needed. We can then proceed to sketch a graph. So questions 8, displacement against time graph. Okay, so this is displacement against time graph. Oops. So we have a x against t, right? And then what is the unit? Well, x is in terms of cm, and then t is in terms of second. And again, now I have a cos function. Okay, and by comparisons, I found that my initial phase angle is equal to 0. So what I have to do, I just have to sketch the cos graph in the questions A. Okay, so cos start from amplitude. So you have a U-shaped graph. And then after that, you just label the value. So maximum value is 2, and then origin is 0. Negative maximum is negative 2. And again, period is equals to 1. Okay, period is equals to 1. Done. That is a complete equations. Okay, by sketching this diagram, you can get full marks in the exam. All right, very simple. So actually, it's very easy to score. Okay, don't be afraid of the graph question. Graph question is very simple if you know what types of information that can be obtained from the graph, or what is the information needed to sketch the graph. Okay, kalau kamu tahu apakah maklumat yang kamu boleh dapat dari graph, atau apakah maklumat yang Anda perlu masukkan ke dalam graph, actually graph punya soalan dia agak senang. Okay, satu gambar aja ini sahaja sudah 3 markah. Okay, it's very easy to score. Okay, now let's look at questions B. Well, questions B again is asking for velocity against time graph. You need an equation of V in terms of time. So V with time, okay, now what is the equations? Well, I don't have the equations, but what I do have once again is the X. So I'm going to differentiate it. So V equals to dx over dt. Okay, so I differentiate the 2 cos 2 pi t. I will get, okay, differentiate cos, it gives you negative sine. So negative 4 pi sine omega t. So omega t is now is 2 pi t, right? 2 pi t. So this is the equations that I have right now. So again, I have a V against t graph. So y-axis is V, x-axis is t. What is the unit for V? Well, because x is in terms of cm, therefore V is a cm as negative 1, and time is a s. I have a negative sine function. Okay, negative sine. So again, I'm going to sketch an inverted sine. Sine yang terbalik. Okay, sine yang terbalik. So this is a shape. And then after that, I just label it. Okay, I just label the value. So maximum value again is not A, but it is A omega. So A omega, I have 4 pi here. Okay, and then origin and negative 4 pi. Okay, negative 4 pi. So next one I have, okay, next one I have a graph of accelerations against time. Question C. A against t, I don't have equations of A in terms of time. Okay, so what am I going to do? I'm going to differentiate V. So A equals to dV over dt. Differentiate sine, I get cos. But now because this is a negative equation, so I'm going to keep the negative sign here. So negative 8 pi square cos 2 pi t. All right, so even though differentiate sign give you cos, but the equations, the V itself already come with negative. So we keep the negative in our equations. All right, so this negative is not because of differentiations. It is because the V initially is already a negative value. So negative 8 pi square cos 2 pi t. So again, I'm going to sketch x and y axis. Y axis is A, x axis is t. Now, what is the unit? If you look at V, V is in terms of cm. So A is also Cm as -2. Time is in second. Now I have a negative cos function. So negative cos, what am I going to do? So I'm going to flip the cos over, right? Terbalikan cos punya equation. So I'm going to flip it over. Now I will update a graph like this, okay? Like N-shaped graph. So this is the graph of A against T. And of course, the last step would be label it. So now label should be A omega squared. So A omega squared give me 8 pi squared. So here is negative 8 pi squared. Here is 0. So again, period is equals to 1. Right? So period is equals to 1. So just make sure you have the axis correct, the right axis with unique, with the correct unique, and then you have the label, the values, and the last step is the right shape, okay, the correct shape. So these three these three examples is similar as the previous questions. So now I give you 3 minutes to write it down, okay, to check your answer. See whether you got everything needed in a graph. Okay, so 3 minit bagi anda catat. Tengok adakah kamu punya graph, kamu punya jawapan semua betul. Kalau betul, okay, bagus. Kalau salah, di manakah kesalahan dia? So I give you 3 minutes to write it down before we proceed to the next question.
Madam,
Yep.
boleh ke kalau saya labelkan juga dekat middle of graph tu? Maknanya half.
Oh, boleh, tak ada masalah. Kalau kamu nak tambah satu label, boleh tambah tapi tak boleh buang dia punya one cycle. Okay, let's say you nak label dekat sini 0.5, okay, tak ada masalah.
Okay, means yang satu tu memang kena ada lah.
Satu itu memang kena ada.
Okay.
Ya, sebab dia period. Period memang dia diperlukan dalam graf kita.
Alright, thank you.
Madam,
Ya.
kalau macam contohlah soalan bagi negatif, dia bagi negatif cos. Lepas tu kalau kita nak differentiate jadi apa?
Kalau dia bagi kamu negative cos, kamu differentiate dia jadi positive sign lah.
Oh, dia putar balik je lah kan?
Dia putar balik saja. Dia memang asyik putar balik.
Okay, thank you.
Okay. So let's look at question number 3. So we are done with XT, VT, and AT graph. Now we are going to look at an energy graph, okay? Energy against displacement graph. So questions 3. Questions 3, according to the questions, now is asking for a potential against displacement graph. Okay, so sketch a graph of potential energy against displacement for a horizontal spring whose spring constant is 95 Newton per meter, which has a mass of 55 gram on the end of it. Assume the spring was started with an initial amplitude of 2 cm. Neglect the mass of the spring and any frictions on the horizontal surface. So first thing, okay, I would like you to sketch the diagram. It is always a good idea to have a diagram, especially when you have a case that involves spring, okay, because of the displacement. Spring sometimes is quite hard to determine whether the displacement is positive or negative without diagram. So now let's see how are we going to sketch the diagram first. Okay, so initially, okay, this is the initial positions of the spring. So initial position, why is it so important? Because it tells you where is your x equals to 0. Right? X equals to 0 before you stretch or you compress the spring. So what happens? According to the questions, now your spring started with an initial amplitude of 2 cm. Positive 2 cm means now you stretch the spring. Okay, because now your object need to be located on the right hand side of equilibrium position in order to obtain a positive amplitude. So if question say it start with a negative amplitude, it means you compress the spring. Okay, you compress it and that is located on the left hand side right now. So now you stretch it. Okay, so now you stretch it, you stretch the spring, so your object is located at somewhere here. Right? So from your object, from this position until the equilibrium position, this is 2 cm. So this is what we have right now. So how are we going to sketch the diagram? Okay, so potential energy against displacement. Now, when this spring oscillates, it's going to have a positive and a negative value. Okay, so why? Because negative, when it oscillates, so a negative would be located at here, right? Object would be located at here. If it become compressed when it oscillates, right? Let me sketch it. So if oscillate, okay, now spring being compressed, so object is located at here. Right. So if you start from a positive 2 cm, then negative value would be negative 2 cm also. All right. If you start from 2, amplitude 2. So you're going to get 2 on the other side, on the other displacement. So when this spring, when you release it, okay, when you release the blue color spring, it's going to oscillate. Oscillate between the purple color and blue color. Okay, oscillate, keep oscillating. Provided if there's no external energy acting on it, no external force acting on it, no frictional force on the surface. So it will just keep oscillating. So how are we going to sketch the diagram then? If you look at the value, I have negative displacement, I have positive displacement. So my graph, okay, my graph should come with positive and negative x-axis. Okay, but y is just a positive value. Okay, because energy, we don't have a negative energy. What we have is just positive energy. So U in terms of joule, and then this is my x. Oops. My x is now in terms of a cm. Okay, x in terms of cm. Okay, now I have the values of x, okay, the maximum x and the minimum x, which is the amplitude. So amplitude actually gives us a maximum x and a minimum x. Okay, this one it represents maximum x. So maximum is 2 cm. So my graph on the x-axis, it should come with a 2 cm. And then the negative x-axis, it should come with a negative 2 cm. So this is the label along the x component. Now, how about the label along the y component? Well, we do have a 0 here. But how about the maximum value? That is the things that you need to calculate. Can you calculate it? Yes, you can. You have enough information. Right? So U, the equation is U equals to 1 over 2. Now, you are given spring constant. Okay, so you choose the equation with spring constant. So U equals to 1 over 2 kx squared. Okay, kx squared. So in our graph, we need to plot the maximum U. Okay, we need maximum U. So U max is equals to 1 over 2 kx max squared. And x max is our amplitude. So you can calculate maximum potential energy by using 1 over 2 Ka squared. Right? 1 over 2 Ka squared. So I have 1 over 2 times, okay, times the spring constant 95. Okay, now you need to remember, because energy is in joule, okay, joule is SI unit. So your A, you need to change it into SI unit. So 2 cm, 0.02 squared. Right, so U is equals to 0.019 joule. So this is the values that you need to put in your graph. The maximum value, 0.019. Okay, 0.019. Okay, 0.019. Okay, now how about the shape of the graph? Okay, how about the shape of the graph? When your object is at its equilibrium position, which means when your object is located at x, okay, at x equals to 0, so your U would be equals to 0. Okay, at x equals to 0, U is equals to 0 joule. Therefore, we know that at this intercept, the origin, this is the lowest point of your potential energy. The smallest value, the 0 joule, it happens at x equals to 0. That is according to equation. And x equals to 0, u is equals to 0. So when you have a maximum amplitude, your u is also equals to maximum value. So your graph, it will look like this. So maximum amplitude, you have maximum energy. So it's actually a U-shaped graph. A U-shaped graph. So when your x is equals to 2 cm, you have maximum potential energy. And when x is equals to, is located at negative 2 cm, it also has a maximum potential energy. That is according to our equation. The equations on the right hand side. So U max happen at X max, right? Happens at the maximum amplitude. So that is the shape of the graph. And that is the complete graph. Complete the diagram. So for this question, because you are given all of the value, therefore you need to calculate U. So if you are not given the values of spring constant, you are not given the mass, you are not given the omega, and the question asks you to sketch potential against displacement graph, then you don't need to calculate 0.019. You just need to give the shape, and then you label the y-intercept as U max. Kamu label di sini U max sahaja. Oops. U max. Kalaulah sekiralah Anda tidak diberi nilai K, Anda tidak diberi nilai omega atau period, Anda tidak diberi mass. Dan Anda tak boleh kira kan. Kalau tak boleh kira, dalam graph you just label it as U max. And then untuk amplitude, kalau tak ada nilai, Anda label sebagai X max sahaja atau A. Atau A. So ada dua pilihan for X axis. But for Y axis, you just label as U max. Alright, so you need the maximum value. You need the maximum value. So that is how you answer questions number 3. So I give you 2 minutes to write it down, including the diagram, so that you can see what actually happened. So yang blue color punya actually represents the positive side of the graph. This is the one in the blue color. And then yang purple color kena compress punya, it represents this part of the graph. So bila objek kamu oscillate, itu yang berlaku. This is the shape of the graph. It keeps going back and forth. Alright, dia tak akan ada sambung dengan line lain dah. Dia cuma ada satu line dalam bentuk U shape sahaja. So dia asyik ulang alik. So 1 minute for it to write down. It's very simple. You guys try questions 4 first. I need to reply a message. Okay, so let's look at questions 4. So questions 4, now you're given, okay, now you look at the graph, okay, even though it's still energy against displacement graph, but now you have a graph of a kinetic energy, all right? That's why the shape is now different. So kinetic energy against displacement. All right, so let's see. A 2 kg, so you're given mass, a 2 kg body oscillate in a simple harmonic motions. And if its kinetic energy K changes with displacement X as shown in figures, so find the amplitude. Now you have something that is oscillating. And again, if you look at the shape of the graph, along the along the x-axis, when K equals to 0, you have the maximum amplitude. Okay, the maximum displacement, that is your amplitude. Now, how do I know when K equals to 0, my object is located at its amplitude? If you look at the spring above, okay, let's look at the spring. Let's take the spring in the previous question as example. What happened at maximum position? So if you look at the diagram, when object is located at here, the maximum position, it will stop for a moment. Okay, it will stop for a moment. And at that moment, we say object is not moving, and therefore the kinetic energy is equal to 0. Okay, so when it's being compressed until it reaches the -2 cm here, once again, the object is stopped for a moment before it changes its direction. And at that particular moment, we say K is equal to 0, right? So K is equal to 0 at maximum displacement, which is the amplitude. Okay, K is equals to 0 at amplitude. Therefore, questions A, straight away I know amplitude is equals to 0.2 meter. Okay, 0.2 meter. Now, questions B, calculate the period. How to calculate the period? I don't have anything, right? I don't have a frequency. I don't have a omega. Then how am I going to calculate period? If you look at the questions, again, you have kinetic energy. So let us begin with kinetic energy equations. So K equals to, now should I use the equations in a K, spring constant, or M omega squared? Well, obviously M omega squared, because in order to calculate period, I need either omega or frequency. So I'm going to use equations with omega. So K equals to 1 over 2 M omega square A square minus X square. Okay, A square minus X square. So this is the equations that we have right now. So according to the graph, okay, when K is maximum, okay, because we have the values of K at just the maximum point, so at this position, my X is equals to 0, okay? So when X equals to 0, my A is, my K, not A, all right? My K is equals to 2 joule. Therefore, okay, therefore, I'm going to plug it into the equations. 2 equals to 1 over 2 kg omega square, and then my A is now 0.2. Okay, 0.2 square. Okay, because X is equal to 0, therefore straight away equals to A square. Rearrange equations, I will get omega equals to 7.071 radian per second. Right, so by using equations, T equals to 2 pi over omega, and is then equals to 2 pi over 7.071. Therefore, T is equals to 0.89 second. Okay, T is equals to 0.89 seconds. So this is how you solve the question. Okay, this is what I call teknik menjawab soalan. You try to look at the equations and then you try to look at the information needed. Question asking for period. Okay, so can we calculate period straight away? Obviously cannot. But what we do have, okay, what we can calculate is the omega, because we know T, omega, and frequency, they are one family. Right, so if you have an equation that contains of omega or F, then we can try to use it to solve the question. Okay, so everything starts from a word try. If you try, you got the answer, then that means you got the right idea. Okay, if you try, you got the wrong answer, then that means your concept is wrong. So you need to rethink it again. You need to think of it again. Okay, you need to retry it again. Okay, so now question C. Question C is asking for maximum acceleration. So straight away, you just apply the equations. A max equals to A omega squared. Okay, A omega squared. So A we have 0.2, and then omega we have 7.071 squared. So A is then equals to 10 ms negative 2. So that is how we solve it. Okay, so the crucial part is questions B. So questions B, it tests whether you understand the graph or not, whether you know how to interpret a graph or not. Okay, so kamu diberi satu graph, soalan B dia uji, sama ada Anda faham graph tersebut. Sama ada Anda faham apakah maksud setiap nilai dalam graph tersebut. Alright, so once you get it, once you have the idea, once you know how to do it, then you should be able to solve the questions easily. So I give you 1 minute to write it down because the only hard question is the questions B, and then we will proceed to questions number 5. Okay, a very simple questions. So 1 minute for you to write it down. All right, let us move on to questions 5, the last question in exercise 3. So a 0.2 kg object performs simple harmonic motion with displacement x from equilibrium position. So if objects start from equilibrium position, then our graph start from 0. Right? If objects start from amplitude, start from maximum displacement, or start at a certain distance, then we have a cos graph. Okay, so kamu kena tahu ayat dia ya. Kalau objek bermula dari equilibrium, graf kita bermula dari kosong. Kalau objek kita bermula dari certain displacement, okay, atau bermula dari maximum displacement, then it start from amplitude. Sometimes questions won't tell you whether the value given is amplitude or not. It just tells you now you release the object at x equals to 10 cm. So that 10 cm actually represent amplitude. The place where you release the object, that is the amplitude, right? So make sure you know the keywords. Okay, dia nampak macam tak penting, tapi actually it tells you the shape of the graph that you are supposed to have. So a 0.2 kg, so you have m equals to 0.2. So you have a graph like this, determines the amplitude. So very simple, straight away from the graph. So questions A, amplitude, maximum value, which is 8. Okay, 8 in terms of cm. So A equals to x cm. Okay, A equals to x cm. Questions B. Calculate the angular frequency. So angular frequency is omega. Okay, angular frequency is omega. If you want to calculate omega, now you have a graph. So graph, you can obtain period. One complete oscillation, that is the period. So this is your t. T equals to 0.8 second. So omega equals to 2 pi over t equals to 2 pi over 0.8, which is equals to 7.85 radian per second. Okay, 7.85 radian per second. Question C, calculate the total energy. Total energy is just a very simple. You don't even have to look at the graph now because you have the enough information already. Total energy is E. Okay, so E is equals to 1 over 2 Ka squared. Right, so 1 over 2 Ka squared. Now we don't have K, right? So we are going to use equations 1 over 2 m omega square A squared. Now, can we solve it? Yes, we can, because questions gave us the mass already. Questions A, we calculate amplitude. Questions B, we calculate omega. We have all the informations needed to solve question C. So plug in the value, 1 over 2, 0 0.2, and then I have 7.85 square and 8 cm square. Now, cm, remember to change it to meter, 0.08 square. Mega square A square. Okay, so I have 0.0394 joule. Now, actually, you shouldn't leave the answer in this form. All right, it's an improper way of writing down your answer. You should write it in a standard form. So rearrange the equations, you can get 3.94 times 10 to the power of negative 2 joule. And this is what you should do in your report writing test. Okay, report writing test, your answer should be written in this form. You shouldn't leave it as 0.0394. This is 4 decimal place. Exam only allow up to 3 decimal places. Okay, so if you write it in a 0.094 joule, then you're going to get the wrong answer. Okay, 1 mark will be deducted because the exam only accept 2 to 3 dp. Right. So how to write your answer in a correct form? Okay, you change it into a standard form. 3.94 times 10 to the power of negative 2 joule. This is how you should write it. And this is how you should do your report writing test. Okay, where the first digit, as you can see here, the first number, the number in front of decimal point, it's just 1 digit. Now, in your report writing test, I accept up to 2 digit in front of a decimal place. Why? Because the original table given is 2 digit in front of a decimal point. Okay, it gives you 10, 11 point something something, 10 point something something. So I accept up to 2 digit in front of decimal point. Right? So saya terima dua huruf, okay, 2 digit di depan titik perpuluhan dalam report writing test Anda. Sebab dalam jadual diberi, dia bagi kamu 10 point something, 11 point something. So jadual kamu boleh ada 10 point something, 11 point something juga. Okay, tapi when it comes to your gradients and so on, try to keep it at 1 digit. That is the right way of doing a scientific report. Right? So I give you 1 minute to write it down, and then a few minutes to take a short break before we proceed to a new subtopic. Okay, so we'll continue again at the 20 past 3. Kita ambil 5 minute break. Oh, sekarang tinggal 4 minit. 4 minutes break. So 3:20, we will continue with a new subtopic. Right, subtopic ini sudah habis. Subtopic yang berkenaan dengan graph, how to sketch graph, how to interpret graph, we are done. So next part, we'll look at how to calculate period for different types of oscillation, for different types of simple harmonic motion. Okay, kita rehat sekejap, sambung balik pada jam 3.20. Okay, so I hope you guys get ready for the last subtopic and also the last 4 questions in chapter 9. So in this subtopic, we're going to look at period for different types of object. Okay, one for pendulum and another one for spring. So for pendulum, okay, the equations that we're going to use is T equals to 2 pi square root L over G. Okay, L over G. That's why in your experiment 5, okay, where you give me mass affect the period of oscillations, I say it's wrong. Because by looking at this equation, okay, mass won't affect the periods of a simple pendulum, okay, the periods of oscillation. But when it comes to spring, yes, okay, it could be an issue. So T equals to 2 pi square root M over K for a spring. Okay, so you can look at the equations and try to think, what is the things that will affect the oscillations? Okay, the periods of oscillations, the times of oscillation. So questions 1. Okay, questions 1. A pendulum bob is suspended by a light strings of a length 100 cm. So you have L equals to 100 cm, or we say equals to 1 meter. It is pulled aside so that the string is swept through at angles of 10 degrees with vertical. Now, some of you actually don't understand the meanings of this phrase, 10 degree with vertical. In your practical test video, some of you gave me 10 degree from horizontal. Now you have, okay, let's say this is the wall, okay, the place where you're going to hang your pendulum. This is the vertical line, right? This is the vertical line. So the pendulum, it makes an angle 10 degree with vertical. The 10 degree is from the vertical line, not from the horizontal line. Okay, so dalam video practical test ada bagi saya 10 degree from horizontal. Itu memang tak boleh diselamatkan. Okay, so this is 10 degree. So 10 degree with vertical. Okay, 10 degree with vertical. So this is your length L. And then the question tells you after it is released from rest, determines the periods of oscillation. So to determine the periods of oscillation, straight away you can apply the equation. Now you have a pendulum bob. So it is a simple pendulum case. Therefore, T is equals to 2 pi square root L over G. Okay, 2 pi square root L over G, because you're looking at pendulum. So it is then equals to 2 pi square root 1 over 9.81. So T is equals to 2 seconds. Now questions B. The speed of the bob when it reaches lowest point of its path of motion. So if you look at this question, when it reaches lowest point, what happened? Okay, what happened? So you are looking at the speed. Well, kinetic energy is maximum at the lowest point. Right? So if it's rotate, it's swept through an angles, 10 degree. So let's say this is the lowest point. Okay, your lowest point. Then you have a pendulum at here. Pendulum at lowest point is located at here. So at this position, K is maximum. All right, K is maximum, and X is equal to 0. So we want to calculate. Okay, we want to calculate the values of the speed, which is V. Now, can we use equations of K to calculate it? Apparently cannot, because we don't have enough information. All right. If you look at equations for K is equals to 1 over 2 m omega square and then a square minus x square. So even though at the lowest position, x is equals to 0, but we don't have the mass of the pendulum bob. Therefore, we cannot solve it by using this equation, right? But then we can try to apply some things that we learned in chapter 5 by applying the conservations of energy. So we know summations E initial is equal to summations E final in a motion. So when an object is located at its initial position, okay, this is initial position, the things that we have, okay, now let's say K initial plus U initial equals to K final plus U final. So K initial, I'm going to expand the equation first, mu square plus mg H initial equals to 1 over 2 mv square plus mgh final. So I'm going to take the lowest point as a final position. Okay, lowest point as the final position. Now, how am I going to solve this question? Well, I do know that when the object is located at its initial position, located at here, this is the highest position. This is what we call amplitude. Therefore, at this position, my kinetic energy is equal to 0 because object is not moving. And some more, the questions already tell you, you release the object from rest. Therefore, initial velocity, your u is equal to 0. Okay, so ki equals to 0, you can cross it out. And then initial potential energy. Initial potential energy is a non-zero value. Now, let's take the lowest point as our ground. All right, usually when it comes to this type of question, we take lowest point as our ground. So this is our h equals to 0. So which means at the initial position, okay, this is your hi. So hi is a non-zero value. Okay, hi is a non-zero value. So we are going to keep the mgh initial in our equation. How about final? When the object reaches lowest position, half mv squared is definitely a non-zero value because we want to calculate the v. mgh final, since we take the h at this position as 0, so we say hf is equal to 0. Therefore, we can cross it out. Okay, we can cross it out. So now we are left with mgh initial equals to half mv squared. M and m, because you're looking at the same object, so you can cancel it out. Therefore, we have equation v squared equals to gh initial. G is a constant value. We want to calculate v. So what we need right now is the h initial. Can we get h initial from the diagram? Can we calculate h initial from the diagram? Yes, we can. How? Now, if you look at my diagram, okay, if you look at my diagram, this part of the diagram actually is forming a right angle triangle. Okay, you have a right angle triangle here. So this is, okay, let me choose a color. So this is a right angle triangle. Okay, right angle triangle. So if you take this triangle out, so what we have right now is, this is the length, which is equals to 1 meter, and then the angle is 10 degrees. Okay, so what we want to calculate right now is actually the distance here, okay, the length here. So I'm going to call this, I have HF, I have H initials. I'm going to call it A. No, I don't want A. It's quite confusing. HF, HO, HI. Okay, I'm going to call it just H. Okay. So if H, okay, I want to call it H. I want to calculate H. Why? Well, because when your pendulum is located at the lowest position, the information that we have right now is here. From here until lowest position, this is actually our L because of the length of the pendulum. Okay, they oscillate. So when it reaches the lowest point, the string, the length of the string is still 1 meter. All right, the length of the string is still 1 meter. Therefore, based on this diagram, I know that L is equals to H plus HI. Right? So if you can obtain H from the diagram, then you will be able to determine the values of HI. So HI is actually equals to L minus H. So based on these triangles, the black color triangles, okay, I can say that now cos 10 degree is equals to H over L. So H is equals to 1 cos 10 degree. Right? So from here, I can obtain the values of H. Right? Once you obtain the values of H, you can then calculate the HI. So HI is equals to 1 minus 1 cos 10 degree. Okay, 1 minus 1 cos 10 degree. Therefore, if you sub it into the equation, V is equals to 0.54 ms negative 1. Okay, 0.54 ms negative 1. So the most important thing is to understand the diagram. Understand how to calculate HI. So HI is the difference in height between the initial and the final position. But in initial and the final position, the length of the string is still the same. Okay, just that now your object is located at a different position. So when it's swept through from initial to final position, there is a change in height. So you want to find out what is the changes. Okay, what is the changes? So how to calculate it? By calculating the H. Okay, by calculating this H with a triangle, with a right angle triangles. So once you have the length of the H, you can then determine the values of HI. Okay, bolehlah kamu kira HI kalau kamu dah dapat nilai H. Alright, so that is how you solve questions 1B. It is a bit complicated, but I believe you should be able to understand it. Okay, because now you are looking at the same pendulum. So tak kisah initial atau final, dia punya length daripada origin sampai pendulum definitely is 1 meter. It's 100 cm. Okay, so apa yang terjadi di sini, basically, okay, I'm just going to repeat it quickly. I'm just going to go through it quickly again. So what happened right here? So you have a pendulum. Initial position is here, and then final position is here. Okay, but both of them, because you're looking at the same pendulum, the length is still L. All right, so what we are calculating is the difference in the height. So this is our HI. So in order to calculate HI, we need to find out what is the values of this. Okay, from here until here, what is the value? So this is what I call H in my first diagram. Okay, so the whole length is still known as L, right? The whole length. So this whole thing from here to here is still known as L because you're looking at the same string, same pendulum, same string. Okay, the only difference is now it moved from 10 degree to vertical line. Okay, move on from 10 degree to vertical line. So basically, this is what happened, right? This is what happened. Okay, so I give you few minutes to write it down. Okay, this question is slightly more complicated. I will give you more time to write it down. Okay. So after you write it down, we will proceed to the next question. Okay, kita akan ke soalan seterusnya kalau kamu dah habis salin. So make sure you understand. Okay, make sure you understand this diagram because it's not only in this chapter. You're going to use it in chapter 7, in chapter 6. Okay, because it involves circular motion. So you need to know how to calculate the length and so on. Right, so I give you 3 minutes to write it down before I proceed to the next questions. The next question is just a very, very simple questions. Right, so these questions, alright kan? Boleh kan? Make sure you understand, yeah, how to calculate H, HI, and then with the angles. Sometimes you are given the angles, you are given H, questions ask you to calculate length and so on. So you need to understand this diagram very well. All right, now questions 2. A particles of mass 4 kg undergo simple harmonic motion. Figure shows how potential energy of the system changes with displacement. So this one is very similar to the questions that we did in the exercise 3. Now it asks you to calculate the period of an object. So again, question is asking for period. But if you look at the equations for U, there's no period. The only things that we have is just the omega. Therefore, we're going to use equations with omega. So U equals to 1 over 2 m omega square x squared. If you look at this question, the values given is the values that happens at maximum position. Maximum, maximum, maximum. Okay, so when x is equals to maximum, when x is equals to 0.2 cm, or I would say it is equals to 0.2 times 10 to the power of negative 2 meter, then my U is equals to 10 joule. Okay, so 10 joule, 10 equals to 1 over 2, 4 kg. And then omega square x square is 0.2 times 10 to the power of negative 2. Rearrange the equations. Okay, you will get omega equals to 1118.03 radian per second. Okay, radian per second. So from here, you can then determine the period. So T equals to 2 pi over 1118.03, which is then equals to 5.62 times 10 to the power of negative 3 second. Right? That's why answer give you millisecond. This M here, the M in the answer, the M here, actually it represents milli, bukan meter. Okay, it's millisecond. So 5.62 times 10 to the power of negative 3 seconds. So this is just a very simple questions. Right? So 1 minute for you to write it down, then we'll proceed to the next question. All right, next one. Okay, this question is slightly more complicated. Okay, questions number 3, because you need a bit of visualizations. So 3A, question 3. When a family of 4 with a total mass 200 kg step into their 1,200 kg car, the car spring compressed by 3 cm. Questions A, what is the spring constant of the car springs? Assume they act as a single spring. So questions number 3A, what happens right now is, now you have a car, okay, and then this is a spring below the car, let's assume. Okay, so this is, I'm going to call it MC, okay, MC, the car. So now, okay, now what happened here is, when the family step into the car, okay, this is still MC, so now you're going to add with the mass of the family, right, MF. So what happened right now? The spring being compressed. So let's assume initial position as x equals 0. Okay, x equals to 0 meter. So when the family steps into the car, now what happens right here? It is spring being compressed by 3 cm. Okay, so your x is now equals to negative 3 cm. Okay, so initially we're going to assume as a 0 cm to make it easier. Okay, got the same unit. So initial position is x equals to 0 cm. By adding this mass, the 200 kg, okay, the 200 kg, the spring being compressed by 3 cm. So what is the spring constant of the car spring? So now you have the mass, okay? So we are going to apply F equals to negative kx, right? F equals to negative kx. So based on this diagram, what we know is now this F is actually the restoring force of the spring. So this family is stacked onto the car, okay? So the mass compress the spring. So at the same time, spring will try to push it back with the same amount of force. Therefore, we can say restoring force is equals to W. Okay, the magnitudes of restoring force is equals to the magnitudes of the weight. Therefore, what we are going to write here is mg equals to negative kx. So the mass is 200 kg, and then g is 9.81 equals to negative k, now negative 3 cm, negative 0.03. Okay, 0.03. Therefore, my k is a positive value, positive 6.54 times 10 to the power of 4 Newton per meter, Nm negative 1. Right? So when you compress a spring, okay, the mass that you use to compress a spring is always equals to the restoring force. So if you push a spring with 10 Newton of force to the right, then spring will try to push you back with 10 Newton of force to the left. All right. So that is the according to Newton's third law, your action and reaction force. So the action force in this question is the mass of the family. All right, the weight of the family. So restoring force, which is the reaction force, is the Fs, the restoring force inside the spring. The spring will try to push it back with the same amount of weight, okay, same amount of force. So that's why I write Fs equals to W. So Fs is then equals to mg. mg equals to negative kx. Rearrange the equations, you obtain the spring constant. So in this question, the reasons why we use just the mass of the family, because it is the 200 kg that caused the spring compressed by 3 cm. Okay, it has nothing to do with the mass of the car. Initially, you already compressed the spring with the 1200 kg object. So we take that position as x equals to 0. Now, by adding an additional 200 kg, and that 200 kg caused a compression of 3 cm, okay, therefore, we just use the mass of that 200 kg. Okay, we just use 200 kg there. We ignore the 1200 kg because now the compression is just caused by the 200, not 1400. Right? Soalan ini biasa anak pelajar salah sebab apa? Dia pergi guna mass keseluruhan. Now, let's look at questions B. Okay, let's look at questions B. Now, questions B is different than questions A. Questions B, it asks you to determine the period and the frequency of the car after hitting a bump. Okay, after hitting a bump. So assume the shock absorber are so poor, so the car really oscillates up and down. Now the car is oscillating. Okay, the car is oscillating. So what happens right here? You still have the spring. Okay, you still have the spring. So what happens right here is now this mass, you are going to treat it as one because now this whole thing oscillate together. So you're going to use MC plus the mass of the family in the questions B because now when this spring oscillate, both objects oscillate at the same time. Questions A, you just use the mass of the family because the compression is being caused by the family. But questions B, now the whole car, including the family, is oscillating up and down. Therefore, in questions B, you have to treat MC and MF as one object. Okay, as one object. So now let us calculate the period. So now it's a spring. Therefore, period T is equals to 2 pi square root M over K. Okay, so which is equals to 2 pi square root. Now MC is 1200 plus the mass of the family, which is 200. So divided by K, 6.54 times 10 to the power of 4. So T is then equals to 0.92 second. So once you have period, you can then determine the frequency. Frequency is F equals to 1 over T, which is equals to 1.09 hertz. Okay, 1.09 hertz. So this is a very good question to show you what is the difference between the object. Okay, between these two objects, MC and MF. Questions A, you need to treat them as a separate mass. Questions B, you need to combine them because now both objects oscillating together, right? So this one, you treat as one object. Questions 1, you just use MF. So this questions is a bit difficult, so I give you more time to write it down, okay? So I give you, including the diagram, I give you 3 minutes to write it down. Okay, 3 minutes to write it down. So lukis diagram sekali supaya Anda boleh nampak what is the difference. Okay, so oscillate up and down. Okay, so let us move on to the last questions. Okay, so questions number 3 is just shows you when we use which mass, right? Let you understand what is the difference between one mass and two masses. Questions 4. A simple pendulum of length 80 cm. So now you have a length 80 cm is released on the earth surface at an angle of 8 degrees to vertical. So now again, okay, you have a object, hanging object. This is a vertical line. And then this is the object with an degree, 8 degree, with an angle 8 degree from vertical. Calculate the periods of oscillations. So periods of oscillations, now you have a pendulum, therefore it's very simple. T again is equals to 2 pi square root L over G, which is then equals to 2 pi square root 0.8 divided by 9.81. It is equals to 1.79 second. So when it comes to period, actually it's very simple. You just calculate it by using the equation straight away. Now, questions B is the things that you need to think. Calculate the speed and the accelerations of the pendulum bob when it passes through the lowest point of the swing. So now again, it's asking for the information at lowest point. Okay, at lowest point. So same string, but now it just swings. Okay, it just move. Okay, it just oscillate. Okay, oscillate between initial and a final position. So at lowest point, okay, what happens here is we have maximum kinetic energy. So Kmax means that we have a Vmax. So what is the equations for Vmax? So Vmax is equals to A omega. Now, omega is not an issue. Why? Because we already have period in questions A. But the question is how to determine amplitude. So when it comes to amplitude, in a diagram, in the oscillations, in a pendulum, simple pendulum, you need to know it is a maximum displacement from the vertical line. Okay, which mean just now we have L here. Okay, so we say it form a right angle triangle, right? So this horizontal line actually represent our amplitude, the displacement. Okay, the displacement. So when the object is swinging, okay, we have a lowest point where x equals to 0, and then when it reaches the highest position, we have x max equals to amplitude. Okay, x max equals to amplitude. So actually we are looking at the horizontal line, horizontal distance. So once again, we have a right angle triangle. Okay, this is a 8-degree, and then this is L. And now the things that we want is no longer the vertical distance, but it's a horizontal distance. And that is one of the reasons why we need to use a very small angles, because when the angle is small, then we can assume this A is actually a horizontal line. Okay, that's why we can calculate it by using this triangle. If the angle is too large, for example, you use 70-degree. Okay, if you use 70-degree, so a 70-degree, then you can no longer assume it's a straight line. Okay, it would be an arc, right? It would be an arc. So we cannot derive the equations. We cannot calculate A by using right angle triangle concept anymore if the angle is larger than 10-degree. Right? So that is the assumption. So now, okay, now let us calculate. Okay, So tujuan kita guna angle yang kecil sebab kita nak assume bahawa A ini adalah horizontal line supaya kita boleh kira dengan right angle triangle punya cara. Kalau angle dia besar macam yang ada punya eksperimen 70-degree, then we can no longer assume it's a horizontal line. Okay, dia akan menjadi satu curve. Okay, so that's why di dalam kamu punya nota dia ada sebut. Bila dia, okay, when we derive the equations, one of the important assumption is we assume angle is less than 10-degree. Okay, so now let's calculate the A. So cos 8-degree, and not cos, sine. Sine 8-degree is equals to A over L. Okay, therefore amplitude is equals to L, and then sine 8-degree. Okay, sine 8-degree. So L, now we have 0.8 meter. So 0.8 sine 8-degree. So from here, you obtain the values of amplitude. Okay, from here, you obtain the values of amplitude, which is equals to 0.11 meter. Okay, 0.11 meter. So that is the length of the amplitude, 0.11 meter. So now that we have an amplitude, okay, from period, we calculate omega. So it is equals to 0.11. Omega is 2 pi over t. So 2 pi divided by 1.79. Therefore, Vmax is 0.39 ms -1. So this is how we solve it. Okay, this is how we solve it. So the important part is here. Okay, is to know your diagram well. Is to know where is the amplitude in your diagram. So amplitude is actually the horizontal displacement, horizontal distance in a triangle. Right? So question C. Question C is just a very simple question. So question C. If the same pendulum is brought to Mars with a gravitational acceleration of 3.71 ms -2, would the period of oscillation remain the same, increase, or decrease? So you look at the equations. We have t equals to 2 pi square root L over G. The relationship between t and G is they are inversely proportional. So t is proportional to square root 1 over G, which means When G decrease, T increase. Okay, so in this case, according to the questions, we have G Mars is less than G Earth. Okay, therefore T Mars will be greater than T Earth. So it will increase. Okay, the times will increase. So this is how we answer the question. Now in exam, can you use the value? Can you calculate the time, the period by using 3.71 before you make an assumption? Well, if the questions didn't say explain qualitatively, then yes, you can. Okay, but if the questions ask you to explain qualitatively, okay, so if the questions mention the term explain qualitatively, then means no value. Okay, no value. You can only explain by using equation. Okay, explain by using equations. If the questions say explain quantitatively, then you must explain with value. All right, so you substitute the 3.72 just now into the equations, and then you compare the two value. If the question say explain quantitatively, if question say explain qualitatively, then you show the one that I show you here. Okay, the equations you explain by using this set of equation. Now, if the questions didn't mention anything, then it is up to you whether you want to explain quantitatively or qualitatively. Alright, so dia tak kisah. Nah, quantitative ke, qualitative ke, terpulang pada anda. Alright, if the questions didn't say anything. So that's all. Okay, that's the last question for today's class, today's section. So if you don't have any questions, then you may leave the class.